Hello and welcome to today's webinar. My name is Jacqueline Dorsey of Lean Frontiers and I'll serve as your host today. I'm excited to bring to you today a webinar facilitated by Padraig Garvey as a sort of makeup from the presentation at the TWI HR Summit. Padraig will be giving us his presentation from Day 2, Breakout 6, utilizing TWI to deliver significant improvement and engage our people. We'll leave some time at the end for a Q&A session. So for now, let me turn things over to Padraig.
Okay, folks, good morning, or in my case, good afternoon. My name is Padraig Garvey. I am the Operational Excellence Manager for a company called Boston Scientific. And I give a little bit of a background on the company and myself, and as well how we utilize some of the TWI thinking to bring forward our operational excellence journey and trying to engage the organization on continuous improvement and utilizing TWI as the fundamental framework to drive that forward. So just very, very quickly about myself, and I must first of all apologize. I had planned to attend the conference, the TWI conference last May, but due to family issues and reasons, I wasn't able to attend last minute. So really disappointed I didn't get an opportunity to meet you guys and to see some of the excellent presentations that I'm sure would have been showcased during the event itself. So yeah, a pity I missed, and apologies about that. But hopefully you get to see some of the things that we've started to do here in Galway, in Boston Scientific, and what our targets and goals are, and how we can leverage off TWI and even the likes of benchmarking and general operational excellence to drive continuous improvement forward. So a little bit about myself. As I said, I'm Padraig Garvey. I'm from the west of Ireland, a place called Galway in the west of Ireland. I studied in university, in our local university here, studied industrial engineering, and from that completed an internship in Boston Scientific. Once I completed an internship, I then started my grad program here on site. I became a fully fledged employee in 2006. I progressed through the organization for a number of years. I then decided to look at different opportunities in different organizations and different industries, and moved to different organizations throughout Ireland for a number of years. I then returned back to Boston Scientific here in Galway 2 years ago, where I've taken on the position as Operational Excellence Manager. And that role really, the purpose of it is to work with our leadership team and work with our site management team and our employees to drive continuous improvement, to develop operational excellence, and to ensure that it's sustained within the organization, and to drive that forward as part and parcel of everything we do here as an organization. So with that, I'll commence my presentation, and I will hold a session time at the end to answer any questions, but I'm completely open if anybody has any questions throughout the presentation to take the opportunity when it creates itself. So just a little bit of context. So the Boston Scientific Corporation itself, we're a medical device company. We produce primarily balloon catheters, stents, as well as monitors, etc., for the medical device industry, and really focusing on less invasive medicines, how we can help to improve and save patients' lives with less invasive technologies and thinking. We're an organization which produces about 7.5 billion revenue per annum, and worldwide we have approximately 24,000 employees. And those 24,000 employees are housed amongst some of the manufacturing sites, which we have 12, as well as sales organizations, our central corporate headquarters in Boston in the US as well. Boston Scientific in Galway then has quite a long tradition. We're here for 21 years. We're just celebrating our 21 years this year. There are 2,500 employees situated here on site, and we're the second largest site in the network. We have a sister site in Minnesota, in Maple Grove, Minnesota, which employs just slightly north of 2,500. Within the site here itself, we produce 40 different product families, which equates to about 2,200 UPNs, unique product numbers. And we have 50 technologies now. So the 50 technologies would include laser cutting, crimping, automated and semi-automated technologies. So effectively, we're quite a large site and quite a complex site when we take everything into account. We do everything from our base business of balloon catheters. We also develop and produce drug-eluting stents, and we also develop and produce heart valve replacement technology as well. So quite a large site. We also are vertically integrated, so we produce everything. We get the raw material in, the raw material of effectively sticks of metal and pellets of plastic, and from that produce the majority of our products. So we're quite vertically integrated here on site, and we also support other requirements such as lab requirements. So we complete a lot of our testing here on site. We've supply chain here on site. We've got finance, HR. So quite a campus kind of focus. So we don't just manufacture products. We do an awful lot of additional things on top of that. And we're also have quite a large R&D section to the organization here. We've approximately 220 people employed directly in R&D, so designing new products and bringing those new products into market and bring them up to high levels of volume, supported by a manufacturing site as well. Our main focus is however in production, and we have 6 production units, and you'll see the very top row. That's what we call our customer-facing production units. So we've got 4 customer-facing production units. We've got additional sub-assembly called STC feeding into our DES production unit, and at a base level then we've got polymer core technology, which then feeds into all of our customer-facing business units. So effectively, PCT, STC, and DES create the largest value stream in the organization, where that houses about 60% of our employees. The production unit size equates to anything from 250 people to 450 people. So from a West of Ireland perspective, one of those production units would be seen as quite large. Having all 6 together we are actually in fact the second largest employer in Ireland, private employer in Ireland. So we're quite a large site and substantial from that perspective. So that just gives you a bit of a background on Boston Scientific itself and what we do here. So moving on then to why operational excellence. Why is operational excellence important for us as a site? The photograph you see in front of us is just an image of the site with a 380,000 square foot of a plant here, and we're a good site. I would argue, humbly, I would argue that we're a good site. We've shown progression throughout the years. We've developed and we've improved continuously from year on year. We've always given ourselves stretch targets around budgets and around quality improvements, and in the most case, been able to achieve those targets, and in fact sometimes beaten those targets. So we are a good site, and we do achieve what we set out to achieve. So why is operational excellence so important? Why do we need to ensure that we go down a path of operational excellence? Well, commoditization of our products has seen our gross margin been under significant pressure over the last number of years. And that was something that's been quite new, relatively new to the medical device industries. It would have been something that the electronics industries and other industries, automobile industries, etc., would have seen themselves in the past. But the medical device industry, because of its format, was protected from that to some extent. However, due to the large quantity of competitors coming on stream and levels of innovation, our products are seeing gross margin pressures, but there's also significant commoditization of our products, and that drives obviously our sales price erosion. So that, of course, drives us to focus on operational excellence. Obviously, we've also got high competitive environment from not just externally from our external competitors, but also internally as well. We're housed in the west of Ireland, and Western Europe can be a relatively expensive place to do business, and there are other organizations that are in other countries and regions who can do quite similar things that we could do, but at a cheaper price. So we are focused and understand that there are competitive environments externally within outside of the corporation, but also internally within the corporation as well. So we need to ensure that we're doing our absolute best in this. And most importantly, we have a role to play in the long-term viability of manufacturing. We want to ensure that there's a long-term employment in Boston Scientific here in the west of Ireland, not just for the now, not even for 5 years, 10 years, 15 years, but plus 50 years. We want to ensure we create an environment where our kids have the opportunities to work in the west of Ireland and to leverage off the great work that Boston Scientific do and create those opportunities. So we know that the only way that we can achieve those longer term plans is by utilizing operational excellence thinking. That's why we must implement operational excellence. How we do that? Well, effectively for us, operational excellence is all about being the best at what we do. So driving and developing our competencies as best we possibly can. And we have set out 4 strategies to be able to achieve operational excellence and drive competitiveness forward and drive excellence in everything that we do, and to be the best at what we do. Those 4 pillars are: number 1, everybody involved in continuous improvement. Number 2, we have a high performance, highly engaged culture. Number 3, best in industry systems and tools. And number 4, we deliver best in industry results. So effectively, these are the 4 strategies that we focus on to drive and deliver operational excellence to ensure that the site has a long-term viable future. TWI, job instruction and job methods primarily, is a major facilitator for the first 2 and to a certain extent the third of these pillars. And these 3 pillars then will deliver the 4th, best in industry results. By focusing on the inputs of everyone involved in continuous improvement, by high performance, high engaged culture, and by best in industry systems and tools, we will deliver the output of best in industry results. And a foundation of that is job instruction. So the way in which we get everybody involved, we don't just, I think it's a dangerous thing to do to say, well, okay guys, they're all involved, make change. We need to augment that with a structure. We need to augment that with appropriate levels of tools and systems to drive the appropriate level of change. And job methods has been one of the key enablers of that. High performance, highly engaged culture. Well, how do we engage the organization in operational excellence? How do we engage the organization in ensuring a long-term viable future for the plant? Well, we need to engage the hearts and minds of people. Why is it important? To ensure that we have a long-term plant here and our kids can have some place to work. And how we do that is through getting people involved in designing their workstations, designing how they perform their tasks. And that's where job instruction really sits in. So job instruction becomes the foundational tool of driving a high-performance, highly engaged organization, because the experts are the people that do the work. Job instruction gives them the mechanism and gives them the voice to be able to get involved in driving that. Job methods then sit on top of that to help us to improve that even further. What's then very, very important is that we wrap all of our tools and all of our key tools in a key best-in-class, best-in-industry system. So, and I'll speak about this a little bit later on in the presentation, but before we just roll out a tool, we need to ensure that that tool sits within a system, and we therefore need to ensure that that system sits within the operational excellence system and the site itself, to ensure that it just doesn't sit on its own right. It drives higher levels of performance. The system is where the tool will live, and therefore it will have a sustaining mechanism to drive forward. And as I said earlier, these 3 inputs, everybody involved in continuous improvement, high performance, highly engaged culture, best in industry systems and tools, drive the output of best in industry results. And TWI, and as I said, we focus primarily on job instruction and job methods, are the enablers for those things to happen. I'm just going to walk you guys through an example of one of those, and specifically focus on job methods. So a number of years back, we were lucky enough to get Don De Niro over on site and do a little bit of give our management team an overview of what TWI is all about. And then we focused in on job instruction. And for about a 3 to 4 year period, we spent a significant amount of time reviewing our processes, redesigning them, utilizing job instruction methods and techniques to drive forward and develop up, first and foremost, standard documentation using job element sheets. We then trained all of our operators using the 4-step job instruction methods. And then we baselined that, and we started driving standard work and standard assessments to ensure that standard was being maintained and being followed. So we concentrated quite a large number of our work and our time on job instruction and developing standard work. And we incorporated that into our quality system. And as a medical device company, as you incorporate anything in your quality system, it does drive a certain level of activity. And that activity took quite a long time to find its way through. And as I said, you've got 2,500 people working here, 1,800 directly in manufacturing. So to develop and drive standard work across the site took a number of years, and that became the focus for that period of time. That was one of our key strategies. Once we got that to a level in which we were comfortable that it was sustaining, and we had driven a lot of the right types of behaviours, and we'd implemented a robust assessment process to drive forward and identify opportunities for improvement, but more importantly to baseline our standards. We then commenced focusing on job methods. So once again, we got Don over. We've been lucky enough to partner with Don on a number of occasions. Don came back and trained 20 of our frontline staff, our associates, what we term as product builders, and a number of our continuous improvement facilitators, as well as a number of key members of the management team on job methods. So that training session, the 20 people achieved that training, completed that training last October 2014. And then we needed to implement. So we chose a pilot area, and the pilot area is what we call PTA. It's a production unit of about 250 employees. And we used that as a pilot area. It was an area that was rife and ready for this. The management team in that location were absolutely passionate about job instruction, passionate about job methods, and knew that it would drive a significant amount of change. So we felt that area was the right location to start. And we then started to roll out job methods in that case. So the example that you see before us is a real example, handwritten by one of our operators, and one of our operation steps called distal welds. So we got a cross-functional team involved in driving this. So the operators that work on that particular step. In this case, there was 3, and those guys would rotate in and out of that step. We had our PB3, who also builds products and trains, got involved in this activity. With our quality engineer, with members from our continuous improvement team, our lean champion, and our industrial engineer, and we also had numbers of our manufacturing engineering support guys to develop up these. So really a cross-functional team, but absolutely led by the operators, led by the experts, the guys who did this job every single day, and they were one of our key people that we had trained up last October. So they followed the 4-step method, the job instruction 4-step method, for every step within the production unit. So we completed 187 job methods on every workstation across 11 products. But what's also interesting to know is that we also, not just 11 products within the production units, there's approximately 600 UPNs, unique product numbers. So within the 11 products, there's also quite a level of variation, and the team were able to take into account that level of variation. So very, very comprehensive analysis done to drive forward. They also looked at, not only did they just utilize the 4-step job methods activity, they also looked at the station layout understanding how paddock flows, understanding how the equipment is laid out, took photographs, utilised AutoCAD to support. They completed ergonomic studies to assess the ergonomics of the workstation, and then the position of the equipment, etc. online. Once they completed their job methods, 4 steps, they also completed what we call an E study. And an E study is effectively a work measurement study where it utilises predetermined time and motion studies to identify what the allocated time associated to a work step. But what we were able to do was augment the existing E study with job methods. So once you completed job methods current state, we were able to feed that into our software, and that was able to give us an answer. As we worked through the 4 steps of the job methods, we were then able to identify a future state, and that was also fed into our E study. So we now had a very clear current state and a future state, very clear measures of that, utilizing predetermined time and motion studies. So we bridged the gap between the two. We didn't utilize time studies, we utilized the existing E study that was in place. So writing these E study from the job methods really gave us a very, very, very effective way of measuring this. And it meant that we didn't have 2 methods. We were able to utilize job methods as well as these that we already had in place and utilize an awful lot going forward. Sometimes we may have to augment the job methods language with E's language, but the analysis was effectively the very, very same. So job methods then became the mechanism to drive operational excellence. It became that methodology, and it also became the tool wrapped in a system to get everybody involved in continuous improvement, everybody talking the same language, everybody aiming for the same goal, and everybody organized around that to make sure that it happened. And it became the language of the production unit. In the past, we probably would have had siloed thinking where manufacturing engineers, quality engineers, and operators thought differently, worked differently. Job methods was the mechanism in which it was able to get everybody thinking in the same way, utilizing job instruction as well, but thinking in the same way, driving forward in the same way as well. That's how we were able to involve everybody in continuous improvement. But we were also able to engage everybody in it as well. So if people were engaged, their hearts and minds were involved in it. It wasn't just physical activity, it was really getting people involved in what they needed to do and bought into that. And it drove a purpose. Continuous improvement was not just something that had to be done on people. Continuous improvement was part of what they did, as opposed to sitting below the radar. And it really became the mechanism for driving operational excellence forward. One of the key methods of doing that. Albeit this is quite a busy slide. What we're trying to talk about here is taking a broader systems view and a closed loop view of utilizing job methods, and it's about starting that conversation around developing a system. So at a fundamental level, you've got your job methods, and you break down the job into its details, utilizing the 4-step job methods method. As I already discussed, that feeds into an E study. Sometimes we utilize time studies, but primarily feeds into an E study and identifies the time associated with the job. That feeds into our standard Boston Scientific standard, what we call a work content graph. Effectively, a work content graph is an electronic balance board, and it allows us to be able to balance our production lines against tact, against demand. So we're now utilizing job methods to identify the current state work content, how much work is required to drive the level of work that's ongoing, what's the headcount requirements, what's the capacity requirements, and also where are the opportunities for improvement. We utilize then job methods to drive the ideas, teamwork, work together, to streamline those, identify the future states, and team workstation review with job methods to drive forward. That then delivers a future state E study and a future state layout, workstation layout, which once again feeds into a future state work content graph. So we've now gone from a current state to scientifically moving forward to a future state and linking back to our tools in-house. That then further leads to an improvement plan. And you wrap around this again with roles and responsibilities, with leader standard work, with a continuous improvement infrastructure, in which is visual and very easy and clear to see, as well as having the associated requirements and needs in place to drive forward. So you're starting to develop up a system as opposed to just focusing on the tools. And what we're also doing here is incorporating other forms of thinking, like work content graph, but also understanding the layout, ergonomic requirements. So it becomes a very, very, very comprehensive analysis of a workstation, and can lead up to a very, very comprehensive analysis of a production line, and in this case, led up to a very, very comprehensive analysis of an entire production unit, where 187 workstations were analysed, assessed, and improvements identified and driven on. So as I step forward into my conclusions, I do firmly believe there's some things that need to be considered when thinking about not just TWI, not just job instruction and job methods, but also operational excellence as a way of thinking. We've also recently utilised the Shingo model for operational excellence. That's really helped us to bring forward. To help us bring forward that's helped us to bring forward a different way of thinking, and instead of just focusing on systems and tools, to actually bring principles into account. And because of that, I've decided to bridge the gap back to W. Edward Demings, Mr. Demings, a major hero of mine, and somebody who I feel has driven the way of thinking so far forward, is effectively the Einstein of manufacturing systems. And I felt it important to take into account his thinking, which has helped to form some of our thinking, and some other organizations, as well as Shingo, has leveraged off his thinking. So some things to consider is Deming's system of profound knowledge, and incorporating that thinking with TWI. So starting first and foremost is the theory of a system. And Deming would say that a system effectively is understanding the interconnectivities that work together to deliver the purpose of that system. So we must no longer think about that 1-2 doing a 4-step method, or following a job instruction, job element sheet. We must think much broader about that. What are all the interconnected activities that are linked together to deliver the purpose of that system? And obviously that then grows into something quite large and much bigger than just a simple tool itself. We need to understand the roles and responsibilities. We need to understand the psychology of the workplace. We need to understand the tools themselves. But we also need to understand how does that particular tool link to other tools that we use? And how does this system link with other systems? And you form almost an ecosystem of manufacturing. And a change in one can impact a change in another. And all of a sudden your thinking expands much more than that. The profound knowledge also talks about knowledge of variation. And the only way to really truly improve is to reduce variation. And what we found is that utilizing first and foremost job instruction in the appropriate manner to lock down and agree what is the best method, what things do I need to eliminate to reduce variation to drive a standard. Once that standard is in place and locked in, we then utilize job methods to improve that standard. Where we would have stumbled and fallen in the past was we would have driven improvements in an area where stability was not in place and ignored the whole concept of standardized work or deemed it not as important as it really was. We would have seen improvements, and most organizations will mirror this. Not only have we seen improvements, we've been able to leverage off those improvements because we've locked into the standard. One of the key elements of that is to involve the organization again. So the experts on the line are the people who do the work. Involving those in defining what the best method is and documenting that through job element sheets. And once that is locked in, then use job methods. And So basing our thinking here on reducing variation and understanding the difference between common cause variation and special cause variation, and when we need to act as managers and when we should not act as managers to drive improvement. The next thing to think about is the knowledge of psychology and understanding of socio-technical systems. We don't live in technical environments. We live in socio-technical environments where human interaction has a direct play and a direct impact on the performance of a system. So the impact of setting targets, setting arbitrary targets that don't necessarily link back to the system and to the capabilities of the system. What humans will do is they will do everything they possibly can to make that metric go green, to make that performance look like it's really good, even though the system may not be capable, because that's in our nature as humans. If we take a systems perspective of it, we'll identify that the capability issues are there, resolve those capability issues, and drive appropriate performance based on appropriate need. And understanding the interaction between the human and the system, and how those interactions play. The last one then is theory of knowledge, and it's something that I'm quite passionate about and believe that it's after respect every individual and embrace and lead by humility. This is probably the most fundamental principle of operational excellence, the theory of knowledge. So knowledge is based on the principle of prediction, experimenting, testing that experiment, testing the hypothesis, and learning from that hypothesis, and bridging that learning and developing that learning back into everything that we do. So as we reduce variation in everything that we do, we utilize the theory of knowledge and utilize job methods and job instructions to build our improvements. So as I said, job instruction was the first thing that we did, and obviously job instruction is fundamentally it's about transferring of knowledge from one person to another. But by also starting the process of getting the right people involved in designing the job element sheets, and being able to experiment on those improvements, we were able to get more people involved and engaged because it was a cross-shift activity. And people learned and developed their learning from that, and their learning improved. And as their learning improved and increased, performance improved and increased. It also increased the level of expertise, and also increased the level of interest associated with the job. So the job was not just a stagnant, repetitive activity, utilizing the brains and minds of all of our people to build on knowledge, to build capabilities, and to deliver significant improvements. So this is probably a standard slide that everybody on this webinar would have seen before in the past. And we certainly would have been, and probably still are, guilty of the bottom of this blue line here. We've improved, we fall back, we improve, we fall back, we improve, we fall back. Over time, we make gradual improvements, but it is very, very gradual. One of the most striking things about TWI is its ability to be able to lock in that standard, sustain that standard, and then to base the improvement of the standard process. So utilizing job instruction to standardize our processes with a broader standard work system, and further utilizing job methods to drive improvement, and also engaging the organization in everything that we're trying to do. So it's a fundamental principle of lean, fundamental principle of operational excellence. But utilizing TWI has been a fundamental thing of driving this forward, and it's been one of the most powerful ways of doing that we found over our 21-year history. This has been the most significant and most effective way of doing that. I'm just going to close out here on some of the levels of improvements that we've seen utilizing job methods. As I said, this is based on the foundation of job instruction, and this is an example of four of our products in that particular production line. As I said, we've got 11 products in Here's an example of our production lines and distance traveled. So as we transfer forward, we were able to increase output across 3 out of 4 of our products. We were able to reduce our headcount across all of our production lines, and that headcount was redeployed back into the organisation. We're in a very good position because we've delivered on strong performance over the years. This has allowed us to be able to drive forward. We were able to augment that with a significant reduction in headcount and leverage the capacity. So overall, a significant improvement. And distance travelled reduced in most cases. But our productivity, you can see here, increased by 48%, 24%, 77%, and 57% across the line. So significant levels of improvement driven because of utilising job methods. And by managing this in this way, we've also been able to leverage the knowledge and experience of our operators, get these guys involved and engaged in continuous improvement. And drive forward. So significant improvement for the production lines, which is ultimately what we need to do to ensure the long term. So with that, I'll open it up to the audience for some comments, questions, any feedback you might have, or any further clarification that you might require or need. And thank you very much for your time. No questions?